Here I'm going to explain about using the Visual Code Studio as an IDE for developing ROS applications. You need to have installed the Ubuntu machine on a VSL, and then you can open up the Visual Code Studio, as you can see I have done here. I will open it up fully, and as I have been working here before in relation to my Ubuntu machine, then it is booting up the application here. EDA is booting up, connecting directly to the remote on the VSL, my Ubuntu, and even the terminal is given here. So you can work within this environment using terminals. So that's quite good. But how to get that working here? Yeah, there is an icon here for extension, and I have quite a lot of extensions, but you don't mind. If you don't mind that, I will scroll and see if I can find some which is relevant here, and that is the you can see open any folder in Windows subsystem, and that is installed, so you have to install it by clicking on it. You can see here it is installed, and you can uninstall it, and it is explaining here what it does. Let you use VS Code on Windows to build Linux applications that run on the Windows subsystem. You get all the productivity of Windows while developing with Linux-based tools, runtime, and utilities. So that's very good, and that is, of course, also if you write your application in Python, it will be the same. So that is fantastic, and there are, of course, other things you can install, but mainly it is this one which is used here. So if we click here, then you can see here that we can ask for a new VSL window, and that is what you go for to get the connection established. So that's what you need, actually. And then if we look here, that icon here shows the directories, and you can open a folder. And each time we do something in ROS, it's a good idea to actually create a so-called package for it. And we can try to do that here, because you click open folder, and then we have to pick the Catkin workspace always, and when we do packages we have the source in here, and then we say OK. And I trust it, and it takes a little while here. And then we have the folders here, and I have on the image I offer you on the Learn, I have made a package where I include the create, and that is our Rumba, and it is meant for simulation purposes, mainly in Gazebo, if you like to experiment with that. Same for Turtlebot. And there are 3 folders here. Now, if I then want to make my own now, then I have to create a new folder here, and there are icons here, and then I say new folder, that can be called test. And I have my test here, and then it is quite important now to add this folder to the workspace, not to mix it up. And you can see here we have to select it here and say OK. Then it is here an empty folder. And we can then perhaps use examples, or a good idea to use examples from the tutorials on ROS. So if we go there, then we will have the opportunity to play a little bit ROS Wiki tutorials. And let's see, here there are creating a ROS package. We could go directly in here and make inspiration from that. So the simplest possible package, that's the structure. So we need to have a make list file created there and package XML. We could simply try to use. I have already, you can see I'm already there, and then they here suggest that beginner tutorial standard message ROS Pi or ROS CCP. So we could simply take the Catkin create package here and follow this tutorial here, Control C, and then we get back here. And now I want to have a terminal. How to get that? Yeah. Let's see if it is here, terminal. You see, there is a terminal. Then we get the terminal in the in here we have to use this create package and I suggested we created that one. What will happen now is we actually get a folder called beginner tutorial. Anyway, we do that by the script here, and then you can see here we get beginner tutorials, and up here we have the package names called beginner tutorials, and inside we have got the CMake list and the package, and then we have the source directory where the code has to be in. So we are more or less here. Let's go back to the tutorial. Create a package requires that you give it a package name, and that is my package name. That's beginner tutorials, and it is depending on standard messages types, and it depends on ROS Pi and ROS CCP, and that is due to the two languages we can code in. And then we have now to build the workspace, and let's do that also from the terminal here. So each time we have been doing something here before we're using Catkin make, we need to get one directory up here, and then we can call Catkin make, and then it will execute what's in the source file and build eventually a new code. and it is running fast here because everything is built. It is just scripts now we have created. And let's see here. We have now done that. Then we have to source. This one is hopefully in the image. If you use my image, else you have to add the workspace environment and source the generated. So we source the generated setup file. So let me show how to do that. So it's known actually, the code from outside. So we say source here. Each time we source something, it is like executing the script, so it becomes valid. So it's develop, and then the file we have to source is called setup, BASH. What is happening here? Source setup. I think I should remove this one then. Yes. Yeah. And then we can here use this ROS pack depends beginner tutorial, and then we get confirmed that the package is created. We do that here, and then we can see it depends. That was the if we go back here, we said it should depend on something. Here. No. Okay. Anyway, no. But we had a statement here before. We can perhaps find it if we scroll up here. Let's see what goes on here. It's quite many things happening here. Yeah, here we have the dependencies: standard message, ROS-PY, ROS CPP, and that has these two is the languages we can code in, and it is thereby referring to the compiler or script interpreter. And standard message is to get the messages running. Let's go back here then. So then we could go into the beginner tutorials, and if we use this statement, then we jump directly into it. I suppose that's the reason for using the ROS CD instead of CD. Yes, you see, then we are getting it directly, so that's pretty smart. Alternative would be to say CD change directory to source and then to beginner tutorials. And now we want to see what is inside the package XML file created before when we created the package, and that is done by an so-called Linux command cat, so it opens up and we can see what is inside here. And that is a script which is always a part of the environment, specifying different things to include. So, and you can see here it is having these specification ROS-PY, ROS CPP. So, and there we have sometimes to add, to specify more deeply what we want now. Then there is we could also see what the dependencies is with respect to the ROS pi, as we have here. And then we have the generation pi, ROS CPP, ROS graph message, ROS lib standard message. And then we can have the overall dependencies here, and it is again done here, and it is showing all the different code repositories, directories, things we need to have access to when we compile a code. Then we can customize packages. I will jump over that. License, blah blah blah. And then it is here describing more deeply about that, and the final XML file we saw here customized. And it can also be necessary to customize our CMake list file. So that was that, and if we then jump one step up here, let's see if we can ROS packages, ROS topic. ROS packages, let's see what it can offer. Yeah, that was what, this statement has to be in the bash file. Let's just go back to the root, and that is change directory, and then the so-called in Danish tilde. Then we get back to the user space, and then we can say sudo to get access to write and read the bash rc file. And then I have to use the password DTU 62573 exclamation sign. Yes, then we are in here, and if you say that's too small, then you can of course open it here. And in the bottom there are added this source here. And the cat king, and this set is also made, and that must be in your bash file to succeed. I think I have to copy it out and put it in the learn, so you have it. Then each time you start your VSL machine, you have to go in here and change the master GUI and ROS IP each time you boot up. Sorry for that. Else the external node as Raspberry Pi can't find the master running on your laptop. But that's not so hard. And the other things here is set when you set up for the GUI with the X server, as the link show, I hope, in the learn. Yeah, I think I'll take this one out here, Control X. And if we go back here, then they do it here, and remember it is not kinetic, but it is neotic, so the ROS version must be specified here, else it is the same, the rest of it. Then you can we had made this is created first time. It it will be done when you do this Catkin make. Then it will create these directories here and do this here. So you have it here, and then we could make an install. I never do that. And if you only want to specify one file, yeah, then we have to set the path to our source, else it will compile all what is found in the source file. So, and you can see this is actually optional, and we have created that before, and we have done this one, as you saw, and then we have these three directories below Catkin Workspace always. So when we have used Catkin make, then the stuff is made available for running in the build. That means also if you want to recompile something, you need to go in here and remove the folder which is related to the original package, else it is saying it is already there, and then you can't build it again. Yes, let's try to go back again. Understanding topics, perhaps we could do a little bit here. So I think that is quite good to be in here, because here we have to start a ROS core. That can be done from here. So we just say ROS core, but before we do that, I need to change this parameter I talked about before, the IP address. So ifconfig here to see the address, and it is this one here. If we are really lucky, we can say Ctrl+C for copy. Let's see if it works, and then we have to go back here, and then we scroll down here in the bottom, because if this address here is not correct, then it cannot start the ROS core. So let's see if I push the right mouse button here. Yes, exactly, we got it. And we jump with the arrow. Remember, it's only arrows which can be used to move around here. Right mouse button and then Ctrl+X. Yes, done. And then we say ROS core, and then it hopefully will boot up. In a while. Back here. Now it starts. It is very slow, but it is now on its way up. Nice information here where it ups. So unable to connect my own server at, let us see, ifconfig. So I know why. See, each time we have been in here and changing something, we need to source the bat file, else it will not have any effect. So we have to say source. Now it goes fast. Sorry for that. See, source, and then I say ROS core, and then it will start very fast. You see? Now it is, the server is running, and then we have the other node here. This node could also be on your Raspberry Pi, but we do it here for the tutorial. Then arrow up. So the package is called TurtleSim, and the application or node program is called TurtleSim Node. Then you will hopefully see the turtle. You can see it is here. Then we go back to the tutorial here, because now I have got that on. Then the next node we need to run is the turtle tail up key to maneuver the turtle by the arrow keys. So this one, I copy that now, and then I go back here and I ask for a new terminal, and I still want to be in here, and then I run this one. It starts up also. Reading from the keyboard, use arrow keys to move the turtle, you can see. So now it is a little bit tricky, perhaps. No, let's see here. So the arrow keys should be working, and it does not reading from the keyboard. Yeah. Does that mean I cannot see it at the same time? I need to be in this window while I move. So let's see. Oh, we can have this side here. That could be the reason. Yes, it is not slow. It is. So you have to be in this node here, and then the GUI must be beside you. See, it is working fine. Good. So you are going to make an exercise where you are getting this turtle to move in a square. Oh, it's very reactive. Boom. And then backward, forward, boom. You see? So that could also be your turtlebot free moving. For that you need to have the another turtle tail up twist installed, and that is on the image you get from me. Yes, let's see what it says here. It is, then we have this figure you saw here. Then we can also have a graph showing the communication here. We could try to open up a third window or terminal. It does do that, and then the ROS graph is installed. You see here, it is here. And so the nodes are communicating on the topic turtle command velocity. So in the ROS graph we can see the topic here between the graphically the GUI node and the keyboard. So then we can try to actually see which topics commands there is, and it is shown here. So you could even do a publication to the node there on the turtle command velocity topic. Often we want to use the ROS topic list, and you can also show data published on the topic ROS topic echo, ROS echo, and then we could try this one out here, command velocity, and then we could try to use the arrows and see if we can get something there. So we have to say stop this one, Control C, and then we are back here, ROS topic echo. Does not appear to publish yet, so yeah. Now it becomes a little bit hard because we need to go here to I was jumping wrong here. Kører den stadigvæk? Den gik, jo, den kører fint. Kører fint. Lad os så se her. Det er lidt svært at gøre her, fordi den jo ikke publicerer noget, når at det giver ikke mening. Men vi kan lave en ROS topic list to see the topics and the turtle. The turtle we had here up, turtle sim, is responsible for the command, color, sensor and pose. So it is the topics we have here listed by ROS topic list. That's a very good idea to use that. Now, lastly, I think we could perhaps try to see if we can use the rest. You can go through by yourself. I try to scroll down to see if there is a publication example here. Exactly, there is. So we could see if we could use this one here to execute it. I get one up, and then this one would publish and messages for 3 seconds, and that you see here it is now turning, and the reason for it is turning, that is we give it an X and a Z parameter, and then it turns, and if I fire it one time more, then you can see it continues turning, and one time more. So basically a topic message is going to a topic called turtle command velocity, and the message type is a geometric message twist, and then the specification of the parameters. Yeah, I think I will stop this little tutorial here, but the idea is actually you can do everything within the Visual Code node and develop programs in here and test, and even call up applications where you need the GUI.